So basically we'll play a game. We'll play a game, and that game basically is for us to predict a next word, right? So I will give you a sentence. I need to find the last word, right? I play I play in the dash. What's a dash for you? So dash is basically, could be playground, could be park, could be anything, right? Or the next word I can give you is I drink dash in the morning. What it could be? It could be coffee, it could be water, right? And that's how this large language model works. So the large language model is basically trying to predict the next token, the next word, and it will keep on predicting till it finds the right one. So the large language models are built using neural networks. So you might be wondering, what is now neural networks? So you might have heard about that in our brain we have neurons. So that's how the neural network, the neural world word has come from. So neural network is basically a part of machine learning. It's a subset of machine learning, and machine learning is one of the important part that we have to understand if you want to work towards large language models. That is how the large language model works. Training, the important part that we have to understand. The training is the most important part for the large language model to become it as like a ChatGPT or Claude or Gemini, whatever you're using at the moment. The training is done, has to have come with a lot of things. You have to understand a lot of things. For example, maths. In the mathematics, you remember, like we used to study about vectors, about matrices, right? We used to study about integrations. We study about not integration, integrals. The sigma sign, if you remember. So all of that actually is basically part of all of that. So one thing which is there in the large language model is maths. So this is going to be a bit more technical. I might be diving a bit more technical into it, but it's very necessary for us to understand what's happening is large language model actually makes the word and call it as a token. So it breaks the token. For example, you have a word called unbelievable, right? So how can you break it logically? You can think of it. You can break it as as one token, believe as another token, and able as another token. So there are three tokens, right? So what the large language model or what the neural networks they do is they represent each token in some graph, right? You might have understood, you might have read about the graph. How does the graph works you might have looked into in your previous sessions when you were used to study mathematics in your year 10. So it takes the unbelievable, it puts into some spaces in the graph, and it points it like, gives it a number, like for example 1 2 3 3 4 5 6, these numbers. And that's how the model tries to learn and tries to predict the nearest token near it, right? For example, now I have something called, I have to train the large language model that if something happens very surprisingly, I should be saying two words, either awesome or unbelievable, right? Now you said like the way the batsman in the cricket, I will just use the cricket analogy because cricket is something I've been fond of. So in cricket, a batsman has done has scored 6 sixes or hit 6 sixes in an over. What's the next thing you would say if I did this thing? You would say awesome, wow, or unbelievable, right? You could say all of these three words. That means, see, my father is doing the painting in the back, but that's okay, we can just continue. I was also doing the painting. So actually it reminds me a scene of where the movie called The Pursuit of Happiness, where the Will Smith is actually painting. My father is doing the painting in the back, but so basically once the input, you receive the input from the text, it's basically fed to each layers of neural networks. Those layers are basically could be hundreds or dozens or millions, and the last layer is basically responsible for bringing out the output for you. Yeah. So I think I'm just going to give you a bit of an analogy at the moment. So just consider that you are a teacher and you are teaching a child, right? And child is still learning to read a book or read the sentences, I would say, in the more simple terms. So once a child is trying to learn or trying to read that sentence, let's say he's reading a sentence called, I am playing in the park, right? And for some reason he or she is not, the child is not able to read the park word properly. Okay, maybe he reads, the child reads it as a par, or maybe pair, or it could be anything, right? Yeah, just an example. So what you will do instantly, so as a teacher, you would be trying to teach the child, it's called park, right? And again another child comes and it tries to read some other word differently, and at the same time you will say, no, that's not the right word, this is the right word, right? Exactly the same way this is done. The large language models, when you call, they are 100 billion parameters, they are 200 billion parameters, whatever it is, it's basically the number of tokens that are being fed in the training, right? In the training that's being fed. Right. So let's try to understand with some example, right? So how would you do the embeddings for a very simple example? Let's say you have something called the words you have is called big, small, smallest, right? Or maybe you have words like dog, cat, or kitten, sorry. So you would like to place these words or tokens somewhere in the graph, very close to it, right? As you can see in the example. So with this example, you can see if I'm trying to find, if I'm getting an input for the same thing called dog or a cat, then I might have wanted to understand that basically what could be the nearest word, next word it could have. That's the only job of the LLM. They have to find the next token. They have to find next word. So basically the next word could be a dog is sitting on a mat. A dog is sitting on, it could be something. And then that's how basically the LLM tries to keep predicting until and unless it's able to find the right probability or the more probability. Now you might be thinking that even after going through this, there might be some sort of the errors might be there, right? How it is trying to backtrack it. So there's a function that is called gradient descent. So the gradient descent is basically a loss function that we're talking about. So there's a loss function. That means how much is the error they have occurred while finding the right token, right? For example, dog is sitting on a mat. The mat word has got 0.83% probability, right? And the other, it could have a table or maybe bed could have 0.50 or 0.3, whatever it could be, just as example. So once the input actually goes into the layers of neural networks, it goes again and again, repeats again and again, billions of times till it finds the right word. Okay. Now the very important thing is, how is this still trying to do? There's a bit of a maths that we have to understand, right? That's a basically, I might go into deeper into, as in the subsequent chapters or the series. So we'll dive into each of these embeddings and vectors and, in gradient descent, the loss functions and everything. Let's go ahead. And actually this part of the process of, going into layer by layer, and then trying to find the right probability or the right word is called forward pass. That's what I'm talking about. So forward pass is one of the important steps that happens. Basically it tries to send the input text into the layers of neural networks. Yes, layers, that means there are multiple layers of neural networks. I'm not going much deeper in this, just because I'm just gonna talk you how it happens. So it goes into multiple layers of neural networks, right? So for example, if say the dog is sitting on a mat, right? The word mat has got some probability, and that's basically the probability. Is some function, there's a method that the way they call the system, the model actually calculates the probability, right? So the more the number of layers it goes through, is basically we are trying to understand that the large language model will basically be coming to the right probability or more the probability. So training the model with some good data will basically, it will try to give you the answer. For example, if I give it 100 sentences where the dog is sitting on mat about dog, and out of that there are 50 sentences that says dog is sitting on a mat, then it might give you the dog sitting on a mat. No, that's not how LLM works. So that's something, the interoperability. That's where the interoperability comes into play. The interoperability is something which is basically that I still believe that the people in the industry are trying to understand it, how it works in the behind the curtains. We're still not able to find that. I think maybe I'm still doing some research, maybe I'm able to find it, but we are not sure how it is doing that, right? So basically I'm able to explain you about like how the ChatGPT is working. The same thing, GPT is got multiple models. It's got O1, not O1, O3, 4.0, 4.1. There are many models available by them, so each model has got its own weightage, and basically they put more emphasis on something that has to be, that they are trained on. For example, could be trained on the coding. So for example, 4.1 is trained on coding, right? So yeah, it's good in coding because, and you can use API. 4.0 is also good in coding, but yeah, they're trying to make it generally available. But this is how these LLMs works. The underlying architecture, the major architecture, or would be the most architecture used in most of the models is called transformer architecture. So here you have this vector embeddings, you got the positional vectors, embeddings, forward pass, right? Yeah, all of these are basically part of it.